Hello, today we're taking notes on page 150 in our course book. So to start off, we are talking about what is speed. So we're going to draw a picture without any words or numbers. And I drew Mr. Sonic the Hedgehog because he goes really fast. So let's talk about what speed is. So speed is a way to describe motion. Specifically, how much distance an object traveled in a given amount of time. So when we use words like speed and fast in everyday language, it might sound like we're talking about speed in science, but actually the definition for speed is very specific in science. So remember to put on your science hat when we're in this class, and we're going to think of the definition of speed as not how fast you're going, but as in how much distance is traveled in a given amount of time. So today we're going to practice that science definition of what the word speed means. So for example, if an object is traveling at a speed of 30 miles per hour, which is abbreviated as mph, how far will it go in 2 hours? So if I know I'm going 30 miles per hour every hour, it's asking me how many 2 hours, I know that's 60 miles. So that math that I did was 30 times 2 is equal to 60 miles. So how far will you travel in 3 hours? Well, if we're doing 30 miles per hour and we're doing 3 hours, that's going to give me 90 miles. All right, so then what is velocity? Velocity is speed and direction. This is what we call a vector quantity, meaning it has a magnitude, which is what you would call speed, how strong it is, how fast it is, what magnitude means, and a direction. So the only difference between velocity and speed is that velocity is a vector, meaning it includes direction. So direction could be north, west, east, south, north-south, northeast, any of that. North-south isn't a thing, but you know what I mean. It's a direction that is included with the magnitude, which is speed. So if a car is traveling from Charlottesville to Florida at a speed of 50 miles per hour, what will its velocity be? So its velocity is just going to also include its direction. So it's 50 miles per hour south, because we're going from Virginia, which kind of looks like this guy, down to Florida, which kind of looks like this guy. I used to live in Florida. It was a very long drive south. You just take 95 south for like a day, and you get to Florida. All right, so we're going to circle speeds and put X's on velocities. So if you want to pause the video and do this on your own, you're welcome to, but I will also share what I got. So remember, speed is a magnitude, so how fast I'm going. Velocity has a magnitude and a direction. So I'm going to circle my speeds, which is meters per second in this case, and X's next to things that have direction. So like here, this is kilometers per hour north. That's what the N means. This is just the distance. This is 10 meters. This is a distance. I don't have to do anything with that because that's not what the directions told me to do. 2.6 hours is just the time. I don't need to do anything with that. 12 miles per hour up a hill. So in this case, up a hill is a direction. So that's getting an X next to it. 15 minutes is just the time. 641.3 kilometers per hour. That's a speed because it's how fast something is going. It has a magnitude. And here, 0.4 meters per second left is a velocity because it has how fast it's going plus a direction. So what we're going to be practicing for the next couple of days is how to calculate speed or velocity. The way you calculate speed and velocity is pretty much the same, except velocity will always include direction. The formula for calculating speed is equal to distance over time. Distance over time. That's what the d over t means. And we're going to be practicing using this chart, the little triangle chart, to help us remember the formula. So you can think of this as the same thing as that, because S is equal to d over t, like that. And it's going to come in handy when we have to do harder problems. Okay, so some examples of units you would see for distance, time, and speed as follows. So if you need to pause the video and record these down, please do so. Some examples of distance you will see is kilometers, miles, meters, millimeters, centimeters, seconds, hours, and minutes, or time. And then speed, the units for speed is going to be distance over time. So you will see the fraction bar or the division sign, because that's how you calculate speed. So it's kilometers per second. That's what a fraction bar means, per. So miles per hour, kilometers per hour. These are all just examples of units you would see for distance, time, and speed. Okay, I'm going to flip over to page 51. So on page 51, this is a problem-solving method to practice solving some of these speed questions, which sometimes will require a bit of math. I'm also going to try and review just some basic math in case we forgot over the summer, which is totally fine because people forget. So why not review? So you might have used this in the past, but this is called the guess problem solving method. And what it stands for is that you start with a given, so what the problem tells you. Then you go to the unknown, what you want to know. Then you're going to choose which equation you're going to use, or what formula. You're going to substitute. So you're going to replace letters for numbers from your problem. And finally, you're going to do the solution, which is doing the actual math part. So this is meant to help you do these problems. Once you're an expert and you get them right all the time, you don't necessarily have to use this method. But to start, we're all going to use this method so we know how to do these problems correctly. All right, so our first problem is James drives 100 kilometers in 5 hours. What is his speed? So we're going to use our guess method to set up this problem. So G is the given. I am given 100 kilometers, which is a distance, and I'm given 5 hours, which is a time. So I'm going to label what's given to me, distance and time. What do I want to know? I want to know what the speed is. So I'm being asked to find speed. What formulas do I know for solving speed? Well, we just talked about that. Speed equals distance over time. So I know a formula to find speed. So I'm feeling pretty confident. So now I'm going to substitute or replace the letters for numbers. And I only know the numbers for D and T. So I'm going to replace D with 100 kilometers and T for 5 hours. Okay, so now I'm just going to solve. So I'm doing some division here. So if you need a reminder on long division, 100 over 5, you push off the numerator into your division house, like that. And then you can do some long division. 5 goes into 10 2 times. And then I got some zeros and zeros. And then I add a placeholder 0 there. So 5 goes into 20, or excuse me, 5 goes into 100 20 times. Okay, try not to use a calculator. It's always really good to practice some basic math skills. Okay, so that's how I got my solution here. So example 2 is Megan drives her scooter to her friend's house 9 kilometers away. So I already know that's a distance. It takes her 0.5 hours. That's a time. How fast was she going? So fast is another word for speed. So let's use our guess method. We already labeled our D and our T. Sorry, I'm running out of space. Okay, so I labeled my D, my T, and my G inside my G box. I want to know what the speed is. I know a formula for solving for speed, which is S equals D over T. I'm going to replace the letters for the numbers I have, which is 9 kilometers over 0.5 hours. And then I get my answer. So if you need a little refresher on, I don't even know how you can see that. A little refresher on, there we go. That long division, it's there on the bottom. So I push my numerator off the top, put it in my division house, and I'm doing 0.5 into 9, which is how I get 18 kilometers per hour. So there's a little review on how to do long division with decimals. All right, so those are our notes for today. Remember to pause the video and copy it as you go.